Hello guys, this video I'm going to show you how to rotate a linked list. So given the head of a singular linked list and a number k, rotate the linked list to the right by k nodes, right? So for example, I have a linked list like this: 1, 2, 3, 4, 5, for example, right? There are total of 5 nodes in this linked list, and k is, let's say, 2, k equal to 2. So our goal is to rotate the linked list to the right by k node, right? So we need to rotate 2 nodes to the right, right? So the first node is 5 to the right, mean I'm gonna take it out and plug it to the end of the head of the linked list, right? First node, we need to rotate 2 nodes, right? Take 5 out from the rightmost, right? And plug it to the head of the linked list. So it will become 5 to 1 to 2 to 3 to 4, and 4 now is no longer point to 5 but to no, it will become the tail, the new tail of the linked list. So we need to rotate one more time, second node, right? Again, take the last node out, the node that is on the right of the linked list. Take it out and plug it to the head of the linked list. So it becomes 4, 5, 1, 2, 3. 3 now spoil your node and become the new tail, right? So as you can see, if k equal to 2, essentially we are taking the sublist of side 2 from the end of the linked list, and we kind of connect this sublist to the head of the linked list, right? 4 and 5, the sublist is now at the head of the linked list, right? For the case of uh, rotating 2 nodes to the right, right? So that is basically how I wanna implement this algorithm. We need to somehow locate the k nodes at the end, the last k nodes at the end of the linked list, right? And kind of connect it to the head, right? But how to find k nodes that is at the end of the linked list, right? Yeah, for this problem, right, we need to solve, which is find last k nodes of sublist, right? Here's something we need to solve. So how to solve this problem? In order to solve this, we need to know the uh, what we need here is the total nodes, right? Uh, Actually, here we need to go to this node, right? And this will become the new head of the sublist. We also need a reference to the end that later will point to the head, right? Sorry, this one point to the head. So it form a new linked list, right? So we need total nodes, right? And total nodes minus case will be um, minus k will be the number of nodes we need to skip, right? Of node to skip. So for example, k2, there are total of 5 nodes. So we need to skip 3 nodes in order to reach the head of the sublist, right? Of side k. So there are 5 nodes. We need to find 2 last nodes, right? The sublist of 2 last nodes. So it means 5 minus 2 is 3, which is here. We need to skip 3 nodes, right? For linked list, we have to start from the head of the linked list, right? And we start to count, right? So uh, so we need to skip 3 nodes here, right? In order to reach the node 2, sorry, the original linked list should be here. We need to skip 3 nodes in order to reach 4. So we need to skip 3 nodes, right? Total of 5 nodes. Uh, 5 minus 2 is 3. It means we need to skip 3 nodes, right? Next step, we go to node 4. Go to node 4, right? And make for the new head of the linked list. Okay. Go to 5. Go to node 5, which is the end of the sublist, and make connect 5 with current head, right? What else we need here? We need um, to make new tail for new linked list, which is in this case 3, right? 3 will be the new tail. So 3 is actually the node that is right before the sublist, right? Node right before sublist. Okay. Okay, that is the outline ways of how to solve this problem. Okay, let's try to code it down. We need to count the node first. Count the node. Right? Let's say let count equal to 0, right? We need a current working pointer. Initially is head, right? So as long as the current is not null, I'm gonna, which means the current node is not null, I will increment count by 1 and move the pointer to the next node, right? So current is current of next. So we exit this loop when this loop when the current is null, right? So here current is null and count is a number of nodes. So let's make the variable name more readable here. So let's say number of node. Okay. So now we have the number of nodes. But probably I want to take advantage of this loop to also find the current tail of the linked list, because we will need the tail of the linked list, right? Here, go to the tail of linked list, connect current tail with current head, right? Okay, so how to, so here I will let's initialize the tail. Let's say it old tail initially is null. So if the current dot next is okay, so if the current dot next is null, it means the current is a last node, right? So I want to assign the current to the tail, right? Old tail will be current, right? Okay. So next step, we need to by the way, here one important thing to notice here is that k can be larger than the number of nodes, right? Which means, for example, here, for example, the number of nodes is 5, and for example, k is 7. So it means I need to rotate to the right by 7 nodes. But actually, the first 5 node after rotating the first 5 node to the right, the new linked list will become same as the original one, right? So we have, after rotating 5 nodes, we have 2 nodes left uh, to rotate, right? So actually, for the case that k is equal to 7, it is the same as 2, right? And if k equal to, for example, we rotate 5 nodes and continue to rotate 5 nodes, and we have 10 nodes, and 10 plus 2 is 12, so k equal to 12 is also same as 2, right? So what it means is, if I take the result of k modular to number of nodes, I will have the k, the simplified versions, right? The minimum step that I need to rotate. So for example, let's say 12 divide by 5 and take the remainder. 12 divided by 5 is 2, with the remainder 2 also. So here is a way of simplifying the k, right? So I will have to simplify k here. So k is equal to k modular of number of nodes, right? Okay. So next step, we need to skip actually, let's say nodes to skip. Okay, so let's say const skip nodes is equal to node to skip equal to the number of nodes minus k, right? K is the size of the sublist, right? So actually, we need to get to 4, but also we need a reference to the node right before the sublist, right? So node to skip here, so 5 minus 2 is 3, is a number of nodes to skip, right? But I want to, actually in this case, I want to go to 3, and if I can go to 3 first, then I can go to 4, right? It is the next of 3. So in order to go to 3, the number of nodes I need to skip is the total nodes minus k and minus 1. Okay. Okay. So let, because I will modify it, right? So as long as go to new tail, which is this one, the node right before the sublets, go to new tail. So in order to go to new tail, I will again start at the head, and as long as node to skip is still greater than 0, I want to move the current to the next one, current to the next, right? And not to skip is for each node, right? After visiting each node, I will uh, decrement the nodes to skip by 1. So when the node to skip is 0, I will exit the loop, and it is when current is at the, for example, we need to skip 2 nodes, right? So after 2 iterations, I will get to the target node, right? Yeah. So current now is the new tail of Linkedlist, right? And the new head now is actually the current.next. Okay, and after all, I will return the new head. But before that, I want to kernel is a new tail. I want to first what I want to do here is to point the new tail, right? Which is current make new tail, which is current.next will be null, right? The tail will point to null. And also I want to connect sublets with old head, right? So it means the old tail next will point to the current head, right? Okay, I think that is it. This problem is from test 6 and 5. Hope it will work. Okay, it works. Perfect. And make sure that it actually ran the code that I've written. Okay, perfect. So that is it for this problem. Rotate the linked list. And thanks for watching. See you in the next video.